Hello, friends. My name is Bhargav, and I'm here to give a talk today on computational social science with Python and how open source transforms academia and research. So a little bit about me before we get started. I'm currently a research fellow at the Knowledge Lab, which is a lab here at the University of Chicago. I'm interested broadly in the philosophy, history, and sociology of AI and its development. A little bit of what I've done in the past. I've authored a book on NLP and computational linguistics with Python. I've published in cognition, machine learning research, computational linguistics, and related stuff. And I finished my master's in computational social science, which is what I'll be talking about from here at the University of Chicago. I'm a huge Python nerd. I've been just doing this for 6-7 years now. I love the PyData, PyCon community. I've met a lot of other speakers here. I met a lot of people who will be seeing this talk too, I'm sure. I miss, being in person with you all, but this is the next best thing. So let's do it. Cool. So I'm gonna, just jump right in with the obvious question. What exactly is computational social science? Now, easily, at least one part that is straightforward is it's in the name, it's computational approaches to social science research. Now let's break this into two parts. You can already see on my slide what I'm going to say, but basically, when it comes to social science research, there's a lot of social sciences, right? It's an academic discipline to start with, and commonly, of course, it really depends on the university or the country which decides, which science is a social science or a natural science. But normally, it's economics, psychology, sociology, political science, anthropology, and history. And, sometimes some people throw in philosophy there, if that's humanities or not. But basically, these are usually what you would normally call social science. And economics is largely the study of economic systems. So like macroeconomics, which is like a whole country, and micro, which would be smaller firms. Psychology is, the way we think and the way we react, the way our brain works, and the way we do various things. Sociologies are social relations. Political science studies are political institutions. Anthropo means human, so it's the study of human relations and human history, and how humans behave in history as well. History. So this is again like a very, very basic kind of introduction, right? There's just so much going on. These are massive fields with their own histories, and they're very old fields. A lot of these are at least about 120, 130 years old, and people get PhDs in all of these things. And more and so on. And there's a lot of course, real world applications. They're all essentially real world things. So those are what the social sciences are. And as for where does the computational part come in? Now, there's a variety of techniques. A few of them are, text analysis, going through large bodies of text, data scraping, which is basically getting data off the internet, data wrangling, organizing your data, machine learning, which is basically, predicting things. And, this is a PyData, so I'm sure a lot of you would know that's going on over there. And network analysis is analyzing graphs or networks of connections. Now, so far, I've just thrown a bunch of words, just like a bunch of keywords at you right now. Let me give you a couple of examples on what is possibly economics, computational social science. One thing which immediately jumps to my mind is, for example, say you're working as part of a policy team, right? And you want to see how a new tax is going to have larger effects on the economy and on people's lives. What you can do is you can come up with a mathematical model of how maybe a tax would work, and then use data and run a computational kind of simulation to see how would this actually end up affecting people. Now, this is an example of a computationally powered approach to social science research. You've had in the past, you might not have as much data or the computational tools, and it would be either theoretical or just a mathematical model, but we can go beyond that now. In psychology, what we can do is we can conduct a large variety of experiments, especially which are computational now, in terms of how do people make decisions in different contexts? How do people work in teams together? And what kind of team setup leads to different kinds of results? And analyzing these kinds of patterns using, techniques such as just, statistical techniques as well, with the large variety of R packages, is also part of what computational psychology research looks like. Computational sociology research now well, I think this is one of the fields which is really especially taken off. Well, I'm biased because I do most of my research in that. But one like popular thing which people are using right now is using data from Reddit or Twitter to mine kind of information and see political polarization, or which is happening a lot right now, at least in India and the US, which are two countries which I'm kind of embedded in. So, and anthropology, you look at human relations with things. For example, how has technology changed the way we live our lives? I mean, I don't want to get started, but like smartphones, and 10 years ago, it's smartphones, and right, it's just a crazy world out there. So just with their technological paradigm, the social sciences are just transforming very rapidly. And this rapid transformation of the social sciences is really aided by Python, which is what like really blew my mind. As I was a computer scientist before I started entering into the social science research, and it was the best possible training I felt I could have had right before jumping in. Now, I thought so I've given you like a very kind of, I've given you a very basic kind of, again, a lot of keywords being thrown at you, right? So I wanted to just give you a general feel of what it kind of feels like, intuitively, what these kind of things would do. Getting into real details would mean you'd have to, pretty much Google it and find out on your own. But what we can do is I'm going to give you one particular example of a project which I was involved in, which is, truly interdisciplinary and sits between a lot of the social sciences. And I think that'll give you an example of, what exactly is possible with Python, open source, and computational social science. So the project which I'm going to, use as an example to tell you what this is called computational synesthesia, or what we call CompSyn for short. So this project was, kind of thought up or, came about at the Santa Fe Institutes, which is in New Mexico here in the US. It's a beautiful place. The Complex Systems Summer School of 2019, where it was 6 scientists. We were a very interdisciplinary team. There's 2 social scientists, me included, a computer scientist, an astrophysicist, cognitive scientist, and a painter, an artist. And we were interested in thinking about synesthesia. Synesthesia is basically it's a neurological trait when different kinds of senses relate to each other in ways which we don't normally. So, for example, people smell colors, or they hear words. And when they hear words, they don't just hear a word, they hear a certain musical sound with it, or they see colors along with words. And my background is in natural language processing and computational linguistics. So we were particularly interested in the relationship between words and colors. Now, you can, of course, the reason we started thinking about this particular problem is when we have like an artist in the mix, an astrophysicist whose job was to study images and colors. And we thought, well, there could really be here something. So the reason I'm, giving this setting is to kind of motivate you in the sense of like, how does, Python or open source fit into like a social scientist thinking process, right? Now, this work was just a bunch of us hanging out and, talking. And now this work's been published in leading venues and journals. So it's really cool to see it moving from, friends and colleagues talking to writing code to creating a social scientific experiment and then just going ahead with it. You can see the GitHub link over there, compsyn/compsyn, which is where we put all of our code. So that's the start. And now I'm gonna tell you exactly what's going on. How did we think of this? So what we thought of was we wanted to see, when you think of a word, let's let that word be fear, for example, or happiness. These are just 2 emotions. There's a feeling that some words have like an obvious kind of color attached to it, right? Like when you think of maybe, I'm trying to think of something that's always one color. And I thought of apple and grapes. And I'm like, well, apples can be red and green, and grapes can be purple and green as well. So that's, not maybe the best example. Let's take orange. Oranges are normally orange. So, some things are concrete and have a color. And some things are more difficult for us to kind of find a color associated with it. Like, for example, happiness or joy or sadness. These are abstract words where normally it feels like we don't associate a color with it. But is there a kind of global synesthesia or even like regional synesthesia where people associate certain colors with words. For example, um, you have like jealousy and envy having the color green associated with it. You have sadness and blue. So there seems to be that despite things not having a concrete representation, there does certain seem to be a color associated with the word. And we thought, you know, we kind of have this intuition behind this as six, interdisciplinary people. How do we use, how do we just use, how do we set up a social scientific experiment, right? Like, how do we make this science? How do we move from our intuitions to science? So what we thought of was, let's just get a bunch of words associated with a bunch of images. So we just used Python's Google search image API so we'd search for a word, we'd get the top 100 images of that word. So for example, I'm going to go with the same happiness, fear, sadness kind of setup. So we would search each of these words. So we'd search happiness, we'd search sadness, we'd search whatever word is, get 100 images. And now when we get images in, computer format, it's RGB, right? We just basically have pixels and, pixels on and spatial arrangement. Now, when humans look at something, we don't think of, like this color. We don't look at this as, oh, that has 300 pixels of this or whatever. And, it's arranged in this spatial. We perceive the colors in a different way. So what we did was we basically got the RGB distribution of each of the 100 100 images associated with the word, convert this RGB representation into a representation called JZAZBZ, which is just, the name of this human perceptible color schema, which is done in this 2017 paper where these color scientists basically look at a word. And there's more to a word than just, the percentage of the different kinds of colors that appear in. And there's like this hue and saturation, and of course the color itself, but it's a little more nuanced than that. And the way we humans perceive it is different. So we basically took these, more human perceptible color distributions. So we get this massive NumPy array of all these RGBs, transform it just using a basic, like a array matrix transformation into this human perceptible color scheme, average all of these 100 images for each word, and boom, we now have like a simple vector, like a distribution of human perceptible colors for each word. So again, like happiness, I'm going to go to the next slide because you're going to see, exactly what's going on. It's really neat. So here, the example, probably should shift to this example because it's the one in the images, but it's a similar kind of paradigm. We tried to, so we did this for a couple of different disciplines. We did for academic disciplines and also emotions. So I'm going to switch our example to disciplines over here, but it's basically the same setup as you can see. So we use WordNet, which is again like it's a standard. It's in natural language processing and computational linguistics. It's basically ways to get hierarchies of words. We get hierarchies of words like this, and then after that we collect the top 100 Google image searches, create the distributions, and cluster it. And the crazy thing was, we found out that even abstract semantic domains, what I mean by abstract semantic domains is emotions or academic disciplines or music genres, which is what we did it on, you would still have strong clustering, even for abstract concepts. I mean, you'd expect like grapes and apples and oranges and mangoes to maybe cluster together because these are more associated with one color. But to have even abstract semantic domains significantly cluster, this was like something which we couldn't possibly have done before. And, just with the power of like Python's Google image search API, a couple of NumPy matrix, transformations, dictionaries to store all of these things. SciPy also has really great like probability, like entropy matchers. And, maybe those who worked in that kind of field would know what I'm talking about. Just measure these entropies. So these are simple, scientific computing, all stuff which NumFocus, supports. Basic scientific computing packages with we had a simple question, like, do people associate colors with words? And boom, from there, like in just 2 days of like sitting together and just programming, it was really hacky code before, as first trials are always super hacky. So we got hacky code, and then we were like, this is really neat. We're seeing like abstract, again, I'm just going to go back to this. We're seeing abstract concepts cluster. We see like a blue physics and a kind of yellow history and yellow like literature and law and anthropology. And this is really remarkable to us. And we scaled this up and we created 40,000 color vectors, and then we released them. And now there's like 40,000 color vectors for people to play around with. And this was like, you can go and check the code out in, github.com/Compson, which I posted before. It's fairly straightforward code. It isn't anything magical, but it was a bunch of different num-focused, open source tools, like just jammed together, and boom, we could, do social science research. And for me, this is just, a kind of example of how Python and, open source research just comes together to create something really cool. Now, I started with that example, but I wanted to start with that example because I think it gives you a direct example of how you can do really large scale, because, we've also, what we're doing right now is we're kind of taking that research a little ahead by having location data as well, location and temporal data, to see, are these synesthetic associations of words constant? Do they evolve over time? And again, it's simple Python code is how we're doing all of this. After we made it open source and, released it on Twitter, you had a bunch of other sociologists, cognitive scientists, anthropologists of color, historians, all coming and reaching out to us being like, wow, this is so cool. And, how do we use your tool? And then it's wonderful. Like, the community is quick to adapt. As I'm going to show you in my note, but, basically it's the move from people using tools like, just SAS or MATLAB, which is also more like natural science oriented and a little more like old fashioned, to, then move from there to Python being really taking off. I think would be around 2014, 15 was when it kind of really took off to hit the social sciences in the way it has now. I mean, so in the past we'd have maybe some social scientists who would be like, okay, I'm a computational social scientist. But now you just have so many. You have, the master's program, which I graduated from, is just one example of this. But you have this across, I'm speaking specifically for the US right now, but I have a lot of colleagues in Europe where I know Cologne, for example, is one center of a place where a lot of this is going on. They have a really great computational social science group. But basically, you just have a lot more social scientists all over the world, whether it's psychology. So they're thinking, oh, how do I just set up a lot of experiments, collect the data, and then run quick analysis? It's on a Jupyter notebook. That's how you're doing it. How do I find out how political polarization, how Twitter has maybe contributed to that? Just do a network analysis of see who's retweeting who. And then you follow these networks and you see, are there certain cliques? Are there certain kinds of people who are tweeting certain kinds of things? Another bunch of research was done with Amazon books to basically see I know in America, the liberal conservative divide is kind of a little crazy because we only have real two parties over here as opposed to Europe, where it's still I don't want to get into that now possibly, but basically a lot of really cool studies on polarization, which you can do using data from Amazon and Twitter, basically see who's buying what kind of books. And all these open source tools like Beautiful Soup, for example, for scraping websites has been really popular. And now, why is this, becoming so important, so necessary right now? There's been what, social scientists call a reproducibility crisis, especially in biomedical sciences and psychology, where, people would run these experiments, offline on very homogeneous groups. Largely would be just college students, maybe male, usually white. And it was basically the kind of, social science is supposed to be more generic and more, it should generalize to larger populations. And this couldn't happen. And a lot of the psychology studies being, done in the past and medical studies being done in the past, just were not reproducible right now. Political science studies as well. And this was, a failure on, just from a philosophical perspective on what science should be able to do. Now the awesome thing right now is you have data sets which are open. You have people making all of their code open as well. So you have an increase in open science. And for me, what, really, really special part of this and something very dear to me is like teaching it. And I think that there's just a huge proliferation of Jupyter notebooks on GitHub. And it was incredible for me when I started a master's in social sciences, and one of the things I was taught was Git. And I was like, wow, this is where we come. This is something which I thought, I'm a computer nerd, so I thought it was really cool. And even though some of my, some of the classmates were initially struggling, I see that after 1 or 2 years of learning these tools, they're like, I can't even do my social science research the way it was done before. It's really paradigm shifting, and it's something which, again, I see with my colleagues and professors and people moving on to these tools. And of course, you have older folks who don't trust it as much right now, but that's changing. And I think it's really incredible with more data, more tools, more teaching resources, just more people doing these things. You have, interpretable and reproducible science. For me, that's very special. And, another easy way to just look at this is check out, look at all the PyCons and PyDatas, and you have just so many more social science oriented kind of tutorials, even if it's not very obvious on the first, because it's used a lot in industry and different, all these network analysis, a lot of the things which I talked about right now aren't just publications or research projects stuck in dusty universities. It's very interpretable to business. Largely, a lot of companies use a lot of these ideas and tools for their, in-house data analysis, even consulting, and a lot of these things. So it's, again, I'm looking at this from a more academic perspective. So it's I'm looking at it from the perspective of teaching and, reproducible science. And, from that perspective, of course, this is, I'm sure all of you who have, worked in a data-oriented position or kind of get about the things which I'm talking about. Now, I briefly wanted to do this because it seems almost not responsible to not have just a little bit about this. But so for us computational social scientists, our work is necessarily socially situated. Now, there's a common mistake which people do, and I don't want to rag on physicists for this, but usually, a lot of people tend to think that science is not political, that science is not social, but science is inherently political and inherently social. Knowledge is social and political. What we decide to be true and what we decide to not be true, and what we decide to research and what we decide to not research, are all political and social actions and decisions. And it's very important for, this is kind of a call to other social scientists and also to those who might be interested in starting, to remind you all that our work has very important consequences. I don't know if you've seen, the documentary Social Dilemma, which came up on Netflix, to see how a lot of social media companies are essentially, where as long as our reasons for doing science is profit oriented, I think it'll be problematic. And if you don't think about class, race, sexuality, and other intrinsic properties in our data and what we're exactly trying to measure, it's going to be very problematic. There's a lot of books, a lot of please reach out. I'm happy to chat about this. I think there's a lot of talks on just about the ethics of data. So I won't be diving into that, but it's again a reminder, we can get carried away that, oh wow, I've demonstrated that happiness has a color, and then you shouldn't get carried away by the things we can do with these kind of tools which we have, and kind of realize the philosophical responsibilities which scientists have. Now, just for those who might want to start doing these things, again, I feel like a lot of information here, right? I just kind of threw a lot of words at you and ran through a lot. I would really check out SICSS, which is school for it's computational social science school with a lot of videos, free videos, tutorials, and code. About a week or two ago, I gave a tutorial at PyCon India on computational social science with Python. It includes, kind of gives you a lot of some of the things that I talked about. It, introduces those concepts, particularly focusing on text and network analysis, basic Python stuff, just like networkx, spaCy, gensym, kind of, very basic, but you can do a lot with it. You can do a lot of real social scientific analysis. So I'm just throwing that link in there. And there's a lot of text in that tutorial, so you can just walk through it and you'd be able to figure it out. I would highly recommend just checking it out. There's a really cool world out there of easily mineable data and experiments you can set up and check out. And well, thank you. That Bhargavader is my Twitter handle, Instagram handle, Gmail, like pretty much everything. GitHub as well, of course. Please reach out to me. I love to chat about this. I would love to give resources and other kinds of tools. I just wanted to do this talk to tell people about, because I wasn't sure if, those who are working in kind of the non-academic kind of part of, data-oriented Python stuff know about the things which social scientists are doing or what even social sciences are. This is a kind of hurried overall brief talk about it. But there's just so much to see and do. Of course, you only ever really learn from actually doing the code. Check out the tutorials, check out Compson to see, how exactly we do what we do. And thank you all very much.